This is another common mixing tank problem question that's asked. So you have your whole setup from the last problem, 10 liters per minute flowing in, 0.3 grams salt per liter, water flowing in, 500 liter tank, 10 liters per minute flowing out. Q of t is the grams of salt in the tank at time t. So last time we set up the differential equation, we solved it with this initial condition, essentially that Q at time 0 is equal to 0. It's fresh water, beginning of the experiment. And now we're asked, okay, when will Q of t be within 2% of the limiting value of salt? All right, so first we have to figure out, well, what is the limiting value? So the limiting value is if we let t go to infinity. So one way we can do that is we just say, limit as t goes to infinity of Q of t equals, okay, well, we're just going to plug in infinity here. So we get 150 minus 150 times e to the negative 1 over 50 times infinity. Well, that ends up being e to the negative infinity. E to the negative infinity is pretty much 0. So we get 150 minus 150 times 0. So it's just 150. So that's the limiting value of salt in the tank. So now when are we going to be within 2% of the limiting value? So there's two ways that can happen. We can either be 2% kind of bigger than 150, or we can be 2% less than 150. All right, so 2% bigger would be 153. 2% of 150 is 3. Or we could do 2% smaller. So that would be 115 minus 3, so that'd be 147. All right. So now from here, we have to pick, which one are we actually going to encounter? If we drew a direction field, it doesn't have to be too precise. We can also use our intuition to do it. This is Q. We have a limiting value at 150. And then, let's say that's the origin. We're starting at 0. This is a stable equilibrium point. We're going to approach the limiting value. The salt is flowing in. The liquid in the tank is eventually going to be really close to the concentration of salt going in. And so this should be, some graph that looks like that. All right, so if we start above, we can get to 2% at 153 by going down. But we're not starting above, we're starting at Q of 0 equals 0. We're starting at this dot. And so what's going to happen over time, it's going to get closer and closer to the limiting value. But then if we have 147 here, which is 2% away from 150, then eventually that's going to hit somewhere, and it's going to give us a value of t where we are within 2% of 150. All right, so the value we want to use is 147 because we started with fresh water. We started with 0 salt in the tank. So we'll approach 150 from the bottom, so 147 grams of salt in the tank will be within 2% of 150. That's going to occur. So the last thing to do is really just to solve for that. So we don't know what the t value is, but we know Q of t is 147, right? And so I'm copying from here equals 150 minus 150 e to the negative 1 over 50 t. And we want to know what that t value is, so we get 147. All right, so first thing to do, let's go ahead and subtract 150 over. So that's going to give us negative 3 equals negative 150 e to the negative 1 over 50 t. Then I'm going to divide by negative 150, so that's going to give us, 1 over 50 equals e to the negative 1 over 50t. See, we can take a natural log of both sides, so natural log of 1 over 50 equals the natural log of the exponential, right, e to the negative 1 over 50t. The e and the ln pretty much cancel, so we end up with just negative 1 over 50t. But now, the natural log of 1 over 50, well, that's the same as negative natural log of 50. Right, this is 50 to the negative 1 power. So I took the negative 1 and I put it in front of the natural log. Then this equals negative 1 over 50t still. And then if we multiply both sides by negative 50, we'll get t is equal to positive 50 times the natural log of 50, and that number ends up being about 195.6 minutes. So it does take a while. That's more than 3 hours. Yeah, a little more. 3 hours would be 180 minutes. All right, so this is how long that it's going to take to get within 2% of the limiting value, 150, when we started with the setup for the tank and the mixing and the inlets and the outlets and the concentration going in, and we also started with fresh water. That's how you can solve these types of problems.